Okay, so we're going to try this again for the third time. Number 37. I assigned some of these problems to really challenge you guys and work out some skills that you need to. So this one specifically was for your denominator. So the factor in the numerator, I have 2 times negative 3 is negative 6. And so I'm going to have negative 6 and 1 for my factors. So I have 2x and x, and to get my negative 6, I need a negative 3, and then a plus 1. Okay, so however method you use to factor, that's what you should get on your numerator. So what I would do on my denominator is factor by grouping. So factoring by grouping is you take and group 2 out of the 4 terms together. And I'm going to group these first 2 and the second 2 together. Okay, so these 2 terms, they have an x squared in common. So I have x minus 2. And these terms, I'm going to take out that negative 1. So I have negative 1 times x. So factoring out a negative makes the x positive and the 2 negative. And I know I've done this right if these 2 quantities are the same. So I did those right. So now I have the first quantity here and the second quantity here. And they both have an x minus 2 in common. And I'm left with x squared minus 1, which is difference of squares. So I have x minus 2, and then x minus 1, x plus 1. So that is how my denominator factors. After that, I'm left with a problem just like any other, just with some more vertical asymptotes, because if you notice, nothing reduces. So we're going to go through our process then. So my domain, and I'm writing it up here because I know I'm not going to have some room. I'm going to need all the room I can get down the bottom. My domain is x such that x cannot equal negative 1, 1, and 2, all from that denominator. Nothing to reduce. So x-intercept is my numerator. So I have 2x plus 1 and x minus 3. And set that equal to 0. So I'm going to have negative 1/2 from the first quantity and 3 from the second. Then y-intercepts. Now y-intercept, I plug zeros in for x's, and it does work better to put it back into the original problem. I'm going to get rid of this negative 6 so we don't confuse it. Back into the original problem rather than here, because the simplified I'd have to multiply some stuff out. Anything that has to do with the y's, you don't have to use the reduced. So I have 0 minus 3, just putting it, all the x's being 0. So 0 minus 0 minus 0 plus 2. So I get negative 3/2. So my y-intercept is 0, negative 3/2. Okay. So then I'm going to go to my vertical asymptote. And again, that's my denominator, my simplified denominator, setting all of those factors equal to 0. So I'm going to get vertical asymptotes at x is negative 1, 1, and 2. Horizontal asymptote, I'm going to compare the degree. Now, if I use the simplify, I have to multiply it out, and I don't want to do that. So I'm going to go back to the original, and the degree of the numerator is 2. The degree of the denominator is 3, so the numerator is less than the denominator. So by the rules, it's y equals 0. I'm getting really good at this graph now. Okay, so I have negative 1 as a vertical asymptote. 1/2 is a 0. 1 is a vertical asymptote. 2 is a vertical asymptote. These are just those imaginary lines. And 3 is a 0. And y-intercept is negative 3/2, so that's negative 1.5. And then horizontal asymptote is y equals 0. And I'm only going to put it at the ends because it only affects to negative infinity and positive infinity. It doesn't affect those middle terms. So I now need to do my interval analysis, and like always, they come from x-intercepts and vertical asymptotes. And if you graph those on your graph, it's much easier to see. Always start at negative infinity, and I proceed and I hit an asymptote at -1. I leave -1, and I get an x-intercept at -1/2. I leave -1/2, and I hit an asymptote at 1. I leave 1 and have an asymptote at 2. I leave 2 and have an a 0 at 3, and I'm running into my graph. And I have room, so I'm going to come down here. So I leave 2, and I have an asymptote at 3. I leave 3, and I don't have any interruptions until I hit positive infinity. Okay, so I'm going to plug these to I'm going to just move this down here so I can see it. I want them all side by side. I like that. Formatting problems that I always do. I always take my time, get them formatted the way I want. Because if I can understand my work, I can understand what I'm doing when I go back to it. Okay, so I need a number between negative infinity and -1. I'm going to pick -3. So I'm plugging it into this reduced. I only care if the quantities are positive and negative. So -3 is going to be -6 is bigger than 1, so that's a negative. This next one is going to be a negative. Then I come to the bottom. I'm going to have a negative in the first quantity, a negative in the second, because I'm plugging in -3, and -3 is bigger than 1, so it's going to be a negative. So I have an odd number of negatives, so the whole thing is going to be negative. So it's going to be down here in this area. I know that there's nothing up here because it says f of x, and f of x it means it's a function, so it has to pass the vertical line test, so I'm only down here with my picture, going towards those asymptotes both directions. So now between -1 and -1/2, I get a nice -3/4. That's where I'm glad that I don't care about the answer. When I put -3/4, I have 2 times -3/4, the 2 and the 4 reduced, so I have -3/2, which 3/2 is bigger than 1, so that whole thing's going to come out negative. If you need to work out the math to prove yourself that it's negative, then work it out. -3/4 and -3 is going to be negative because they're subtracting 2 negatives. And then first quantity here is going to be negative. 3/4 is smaller than 1. Oh, they're both negative. Never mind. So it'll be negative. But 3/4 is smaller than 1, so this quantity is going to be positive. So I have an even number of negatives, so the whole thing is going to be positive, just using my number sense. A negative times a negative is a positive type thing. So it's going to be plus right here. Then between -1/2 and 1, 0. I typically say don't use 0, but in this case we're going to. So if I plug 0 into the first quantity, I get a positive. Plug 0 into the second, I get a negative. Moving to the denominator, I get a negative. Plugging 0 in again, a negative, and a positive. So I have an odd number of negatives, so that means this whole thing is going to be negative. Now, if I would have thought about this, I should have known it was going to be negative because I have to be close to my asymptotes going through the x-intercept and the y-intercept. There's really no way it could have been a negative then positive because then I wouldn't go through this unless I did my y-intercept incorrectly. So this is a check. This interval analysis is a check on what we're doing to make sure we're doing it right. If it doesn't quite go through your point, just make your point a little bigger. Okay, between 1 and 2, I'm going to have to pick a half. How about not a half? How about 3/2? Sorry about that. Okay, so I need 3/2. So 3/2, well, it's positive, so this whole thing is going to be positive right there. 3/2 is smaller than 3, so this next quantity is going to be negative. 3/2 is smaller than 2, so this is going to be a negative down here. It's bigger than 1, so a positive. It's bigger than 1, and they're both positive. So I have even number of negatives, so that's going to be positive, and that's between 1 and 2. If you notice, there's no x-intercept, so that means that this graph is going to come next to this asymptote and come down and go right back up. I don't know how far. I'm not judging that. I just know that it's going to come down and go right back up because there's no x-intercept. So now I need to figure out between 2 and 3. So a number between 2 and 3 is 2.5, which would be 5/2. Again, really lucky I don't care about the answer. 5/2 is positive in this first quantity right there. It's going to be positive. In the second, 5/2 is smaller than 3, so that's going to be negative. 5/2 is bigger than 2, so that'll be positive, and positive in the next, and positive in the next. I have an odd number of negatives, so the whole thing is going to be negative. So I'm going here. Now if now I should have a positive the next time because I have to go through that. So I'm going to use 5, just because 5 is between 0 and positive, or 3 and positive infinity. It doesn't matter. Plug it into the first quantity, the numerator, it's a positive. Second, it's a positive. Down in the denominator, I get a positive, and a positive, and a positive again. So the whole thing is positive, just like we said. So I'm going to be next to this asymptote, up through my 0, and then back down towards my x-axis. I don't know how far this goes up, nothing, but I know it goes up and comes right back down. So I want you checking your answers today because they are even, and I want you to know if you're right or wrong. So make sure you put in the original problem, putting parentheses, sorry, got a glare, parentheses around your numerator and your denominator, and the reason we put the original and not the reduced is what if I reduced it incorrectly. And then hit your zoom 6, and I'm going to move this over so we can see it. So I have my first chunk right here. I have my second little come through. I got my third clear up there. There's ours. And then I got our fourth piece. Now this comes up and comes right back down like ours did, but ours we'll just say is zoomed in. Okay, so I can't see this bump really well, so I can go to my window and give me some more y's to look at. So let's go to max 20. Okay, first chunk, second chunk, third chunk. There it goes. And if you wanted to see what's happening here a little bit better, you could hit zoom and number 2 for in, and then move my cursor. See, I'm moving my cursor over here. I want to know what's happening right here on my graph. So I hit enter, and it's going to show me what happens right there. It comes up, and then it goes back down. Okay, so make sure you're graphing and comparing your answers.